for purposes of this video, I'm kind of starting over here. So section 3.4 are the sum and difference identities for sine and tangent. Many of the problems are very similar to what you're doing in section 3.3 with the sum and difference identities for cosine. It's just the identities that are different, but the process is the same. You're just plugging in numbers into a different identity. Okay, so we've been working on this example here, finding the exact value of the sine of 195. The first thing we need to do is find two numbers from our entire unit circle, the special numbers that we use on that chart, that will add up to 145. So we're talking about 30, 45, 60, 90, 120, 135, 150, 180. Then past 180 would be 210, 225. Any of those numbers that we could possibly add or subtract, because remember there's a difference identity. We could add or subtract to get this to work. Okay? So different options would be to use maybe 150 and 45. That adds up to 195. Or you could use like 135 and 60. That would add up to 195. So we just want to choose one of those options. So, okay, so I'm going to do the sine of 150 plus 45. That means we're using the sum identity. And the sum identity is the sine of alpha, so sine of 150, times the cosine of beta, so times the cosine of 45, plus, there's a difference between the cosine and sine sum and difference identities, is that for sine, the sine actually matches. And then we do cosine alpha, which would be cosine 150 times the sine of 45, sine of beta. Okay, then we have to find the exact values of those, which come from our chart. I'd like to remember all students take calculus. So 150 is a 30-degree reference angle in quadrant 2. So if it's a 30-degree reference angle, that means sine of 150 is 1/2. And it's a positive 1/2 because sine is positive in the second quadrant. Cosine is first quadrant, so it's positive, square root of 2 over 2. Cosine of 150 is the cosine of 30-degree reference angle, but in quadrant 2, which means it has to be a negative. So negative square root of 3 over 2, I believe. And then sine of 45 is quadrant 1, so again it has to be positive. So then we just simply simplify. We end up with square root of 2 minus square root of 6 over 4. Questions? So we're finding the exact value of that number, which is basically a 15-degree reference angle in quadrant 3. But we don't generally memorize 15-degree angles because they're a little bit ugly to memorize, right? Okay, let's do a tangent problem involving radians instead. So tangent of Pi 12ths. Go ahead and find two angles that you could add or subtract to get Pi 12ths. Now keep in mind that Pi 12ths is 15 degrees. So probably adding two numbers together to get that's not going to work. You're going to have to do a difference. So subtracting two numbers to get Pi 12ths. Can anyone think of any off the top of your head that we could use? Okay, so I heard Pi thirds. Did I hear Pi thirds minus Pi fourths? Oh, or Pi fourths minus Pi sixths. That would also work. So you're either doing 60 degrees minus 45 degrees to get 15, or you could do 45 degrees minus 30 degrees to get 15, whichever numbers you prefer. So I don't care which way you do it, because either way you should end up with the same answer. So it's not going to matter, even though the ratios are slightly different, it will still work out the same. Okay, let's now plug that into the tangent formula. This is the way I wrote it down on my paper, so I'm going to go ahead and use this one. So according to our identity, we have tangent alpha, so tangent pi thirds, minus tangent beta, so tangent pi fourths. This is for the difference identity, so this negative and that negative match. And then on the bottom, we do the plus. So the signs switch. If you use a negative on the bottom or the top for the difference identity, then it's a plus on the bottom. If you're doing the sum, it would be a plus on the top and a minus on the bottom, right? Okay, so tangent pi thirds times the tangent of pi fourths. Okay, now we need to remember the exact values of these. So what's the tangent of pi thirds? Okay, so tangent of 60, square root of 3. Tangent of pi fourths, tangent of 45 degrees, 1. Okay, and then those same exact values get used again. So we already found the tangent of pi thirds, which is square root of 3. And we already found the tangent of pi fourths, which is 1. So once we found those numbers once, we just use them again. And now we just simplify. Square root of 3 minus 1 over 1 plus square root of 3. Is there a problem with leaving our answer that way? Yeah, it's not rationalized because the denominator has a square root in it. So technically you should always rationalize, even though that is the correct answer, because it just doesn't look correct because of needing to rationalize it. How do you rationalize something like that? Times by the conjugate. So the conjugate of the denominator. So should I write that down? Conjugate of denominator. So that gives us square root of 3 times 1. Square root of 3 times negative square root of 3 is negative 3. Negative 1 times 1 is negative 1. And negative 1 times negative square root of 3 is positive square root of 3. So there's the numerator. Denominator, we'd go 1 times 1 is 1. And then we have 1 times negative square root of 3 and square root of 3 times 1, which cancels out. That's the whole purpose of the conjugate, so you get your square roots to cancel. And then you have a negative square root of 3 and a positive square root of 3, which gives us a negative 3. So then the top, we combine like terms. 2 square root 3, very well done, minus 4 over the denominator, which is what? 1 minus 3 is a negative 2. Oh, we're still not done. We can reduce this fraction. So negative 2 divides into 2 negative 1 times. And then negative 2 divides into negative 4 positive 2 times. So that could be your final answer. Or if you prefer, you could write it that way, which is probably what your book would do. So is the hard part of this problem using the identity and memorizing the identity, or is the hard part of this problem simplifying the arithmetic? It's really just arithmetic. It's not even algebra. It's just fractions. So algebra is when you're actually got a variable and you're solving for something. Arithmetic is when you're just add, subtract, multiply, divide. I guess the square root makes it more complicated because of that, but this is the hard part of the problem right there. Okay. Here, let's just try a couple more really fast. How long is my video? 9 minutes, okay. Try simplifying. This one should go pretty fast. Sine 7 degrees, cosine 2 degrees, plus cosine 7 degrees, sine 2 degrees. First of all, you have to recognize the identity, because you now need to make sure you know the difference between the sine identities and the cosine identities. So you need to recognize this one as sine, because if it was cosine, these would both be cosine, and these would both be sine. That's what we were doing on the last assignment. But it's sine when you're doing sine times cosine and cosine times sine. So is this the sine sum or sine difference? Sum, which you have to remember from the cosine, it's actually the same sign and not the opposite. Oh, so much to remember. So it's just 7 plus 2. So simplified, it would be the sine of 9 degrees, and that's your final answer. Okay, do you want to try one more? Just to make sure you've got this type of problem. This is what we did earlier. Find exact value of sine alpha plus beta if sine alpha is negative 3/5 in quadrant 4 and cosine beta is negative 1/3 in quadrant 3. I'm going to let you go for that and see what you can do with it.